Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at an oscilloscope that is really inexpensive. It's not this Rigol 1054Z, which I've used on the channel a bunch of times. I've owned this thing for a while now. Great scope, but its $300 or $400 price range is a little bit expensive for the casual person who might want to be trying to do a little bit of repair on an old machine. So what we're going to look at is this. It's the Hantek something or other oscilloscope here. It's USB. It's only $60, so it's nice and cheap. And let's see if this thing is any good. So without further ado, let's get right to it. So I think it's a pretty amazing time that it's possible to get stuff like this for as cheap as what I actually paid for this. It really wasn't that long ago where you had to spend a fortune to get any kind of digital storage oscilloscope. None of these boxes are checked on here to show the model number, but if we look here, there's a barcode here. It is the Hantek 6022BE. And on Hantek's webpage here, it's part of the 6002BE series, and Hantek offers up different models with different bandwidth, and this is the lowest cost one, so I think it's 20 megahertz maximum. I paid just under $60 for this device from AliExpress. I think it might have been like $1 or $2 less actually, because I think it was on sale at the time I got it. But just looking at the picture here, you can see that this comes with 2 probes, USB cable, installation CD, and the USB oscilloscope itself. And if you are not comfortable buying from AliExpress, you can buy from Amazon as well. Here in the US, Amazon Prime for $62. So literally about $2 more expensive than AliExpress. This particular listing is a third-party vendor, so I can't vouch for if this one comes with all the same stuff. But the listing on AliExpress where I bought from says it's the official store of Hantek. Now, I have no idea if this is for real, actually them, or a vendor calling themselves official store. But if you go to the store homepage here, there are all sorts of other Hantek devices that are for sale, including some other devices which I've actually purchased and I'll be reviewing as well on separate videos. But in this video, we are going to take a look only at this device, and we're going to see if this thing can actually allow me to do the troubleshooting I need to do to fix a computer. Now, the main goal of this video is to see if a $56 or a $60 oscilloscope can actually be a useful tool. In the past, I've used this logic probe during troubleshooting, and I think I spent like $20 on this thing, or maybe it was $18 or something like that. While this is a useful tool in some ways, I really don't find this thing to be super useful. And if you're gonna buy one thing to troubleshoot an old computer that's not working, I feel like an oscilloscope is really your best bet. The problem is that oscilloscopes in the past were so expensive, they were sort of a luxury item that were hard to have and afford. Only if you were a real professional would you spend the potential large outlay of cash on an oscilloscope. Otherwise, you had to really rely on tools like the logic probe. So these had a place. But now, when things are as cheap as this, I think the days of having to rely on a logic probe are just over. So let's just take a quick look at the hardware here before we test it out. So there's the main oscilloscope box, metal. What's going on here? All right, well, there's a regular USB port, and there's a little rubber cover here that says USB XI. I don't know what that's about. So I'm just gonna put that rubber cover back on. There are the 2 inputs. There's no trigger input or anything like that. There's a ground terminal, and also I think there is like a square wave output that's good for calibrating the probes. You have to turn a little knob on them to adjust them. Otherwise, that's pretty much it. Here it confirms the specs of this particular scope: 20 megahertz, 48 megasamples per second, which is honestly really quite slow. But I think it's going to be fast enough to still prove useful for at least troubleshooting machines like the Commodore 64 or other 8-bit machines, which run at like 1, 2, 3 megahertz, things like that. Let's see what we got in here for the probes. I don't expect these to be particularly good quality, considering you could spend $100 on a scope probe. Not too bad. It looks like it's 10x or 1x, which is good. You really want to have, at the minimum, a 10x probe. Relatively standard fare here. We have the ground lead. We have a clip here for clipping onto like a pin or a lead. This should pull off, I assume. There we go. So pretty standard affair. Not very sharp, but I mean, honestly, what am I expecting? I got 2 of them here for not much money. There are little rings here. You can install them on the probe. This one has a yellow one on there now. Let's see what color this one is. It's got yellow as well, but you change them because on here there's a blue input and there's a yellow input, which should match in the software, just so you know which probe is which. They've included this little tool here. It's just a little tiny flat blade, and it's for turning, I think it's compensation, I think that's what it's called. You connect up to the test signal here, and you turn that until the signal looks good. I'll do that when I have this thing up and running. Okay, so let's just quickly talk about the capabilities and features. So it says bandwidth is 20 to 200 and up to 250 megasamples a second. That is not this one. Obviously, we saw, I think the spec said it was, or here on the bottom, 48 megasamples a second, so not fast. But if you're thinking about buying an old analog oscilloscope, if you're gonna get one that's not expensive, 20 megahertz is pretty typical. And like I said, that's good enough for working on a Commodore 64, things like that. I've looked around a little bit to see if analog oscilloscopes are still cheap and easy to get. And it seems like, at least here in Portland, that it's not the case anymore. Even the most like basic oscilloscope that works and is not ancient, it's like $150 now. Like the prices have really gone up on those. And for me personally, I've always only used external oscilloscopes like the Rigol 1054Z I have up there. Great scope, very, very happy with it, but it's like 300 bucks is like the starting price, and it's very capable and it's a great scope. But that's certainly more scope than you need to just fix a Commodore 64. I'm pointing to it and you can't see it, but I have the VirtualBench that was donated to the channel, and that's what I use for capturing oscilloscope screens on the PC here. And it's a pretty good scope. It works well, and it's got a lot of other capable features like a power supply and a signal generator, logic analyzer, things like that. But if you go look up the price of the VirtualBench, like for the current version of it, it's like thousands and thousands of dollars. So it's really not a good option for home users. Unless you can get one really cheap, like a used one, I really do not recommend you even bother looking at the VirtualBench. Anyway, back to the spec page. So like I said, this goes up to 200 megahertz, 250 megasamples a second. I did look at some of the higher models when I was shopping, and they were a lot more expensive. Like this is the really cheap one, and the price goes up pretty steep after that. In fact, when you buy like the 200 megahertz one, it's, I don't remember the exact price. It was like many hundreds of dollars. I mean, it was as much as buying the Rigol 1054Z, which is a 4-channel scope and has a screen and it's extremely capable. So I don't know if the value proposition is there once you go up to the higher models, but I'm hoping the value proposition is there for this one. So a couple key points to talk about. It's USB 2 and it does not require an external power supply, so it's powered off the bus. So that's good for just ease of use. It supports Windows NT, and I'm pretty sure on the box it says Windows 2000, so obviously this thing's been out for a while, but I think more so they released the software to work on those really old OSs, because if you're using this in an environment like a manufacturing plant, they might have really old PCs just because it does specific workflow things and they can't upgrade it. So it's nice that this has wide compatibility. So if you are not a fan of Windows, for instance, and I don't even know if this has Linux software or Mac software, then you can obviously use any old laptop you find at the thrift store for $5, as long as it's got some version of Windows on it, and this is actually going to work on it. There was a more expensive version, I think, of this same one though, like the same speed and capabilities, that had a wireless connection on it, and then there's an iPad app. It was quite a bit more expensive than this one for having no other capabilities except for working on an iPad. So I figured that it wasn't worth me testing out, but maybe that will work better for you if this thing even works well. Anyhow, looking through the rest of these features, I mean, it's just all the usual stuff that's like the oscilloscope features, digital ones that is, so that's cool. Okay, got some pictures here. I mean, there's the software. It looks really old. It's running in XY mode there. But yeah, I mean, let's give this thing a test, right? So when I downloaded the software, the date on the file on their website was like from 2014, but the driver file that they had was from 2021. So I'm hoping at least there's good Windows 10 64-bit compatibility, which is what I'm using. And indeed, these are the drivers for this particular one, and they date from 2021. So I'm going to skip the manual, and I'm just going to go right to trying to use this thing. So let's install the software. That's a pretty old looking installer. Looks like it's a 32-bit application, but whatever, as long as it works. And let's plug in the USB cable. Right away, over in Device Manager, it just shows unknown device. So I'm going to manually go to that directory, and I pointed to the driver directory. Oh, there we go. And here is the Hantek app. Let's run that and see what happens. Oh, there it is. All right, so let me connect up a probe. Channel 1 is the yellow probe. And let's hook on to the test signal right there. Okay, so right off the bat, there it is. I have to say the update speed is definitely not very fast. Let's switch this to 10x and put this down to 1 volt per division. Let's see if we can move this down. Yes, we can. All right, horizontal, it's got this knob, that's sort of weird. Okay, so see this little thing going on here? Should be a square wave, so this is where the little adjustment tool comes in with this little pot. And you turn it until you get a nice square wave. And this is, I think, compensation it's called. There we go. All right, and this is the trigger. Oh, cool, you can just drag it. So you can obviously just drag this up and down, no problem. Let's turn off the second channel. So this is really the first time I've ever seen this software, and it's basic, but certainly works. I'm used to the VirtualBench software, which has basically at the top here like a view of the waveform. You can move around, like you can scroll back and forth. This one you can still scroll, you have to drag back and forth. But on the VirtualBench it's up at the top, so it's kind of nice. Plus there's a little like thing to change the time base quicker than this. This has a little drop down, or you can move this like knob thing, which is a bit strange. In the view menu, you can turn on measurements. So there's the frequency, 1.03 kilohertz. And let's turn on peak to peak and top. So when the measurements are turned on like they are here, this is kind of a way to use your oscilloscope as a multimeter. So we know that this signal, or if I was on a DC signal that is, it would show what the DC voltage is there, 2.07 volts. And the frequency, of course, is like a good little frequency counter. Now, one thing I'm not loving is when I turn on all these measurements, it turns this into like a scrolling list. Even though, look at all this space here. Why exactly aren't these things listed more in columns, take up more of the space? That way I don't have to lose all this room of the waveform view. To be honest, these are the ones I would probably keep on anyways. And obviously if you turn on the second channel, it's probably gonna list them, I don't know, I would assume it would have channel 2 here, but that doesn't seem to be the case. So anyways, I don't know, it's not great, but it's workable. Now, one thing I noticed is the update rate is not super fast on this, and you can kind of see it like running at, I don't know, like 5 frames per second or 10 frames per second or whatever it is. And the VirtualBench definitely runs at a much higher refresh rate, and that is over USB 2 as well. I think the VirtualBench actually has the hardware buffers and a lot of more processing oomph in the unit, and it's really just sending like a little window view of what it's capturing to the computer. So even over USB 2, that can update really quickly. I think the Hantek is actually sending everything it captures to the PC. And we can see here by scrolling around, like if I hit pause, it's there, it's stopped. But you see all of this is captured. So it's actually capturing a lot more than just the little part we're looking at. Now there may be a setting to say only send us this, what we're looking at here, and nothing more, or maybe a little bit off to the sides, and then it would update a lot faster. So I'll have to poke around a little bit. All right, so there are, of course, built-in cursors as well. So you set one there, and we would set the other one. Actually, how do I use this? It's a little fiddly. Okay, I see. You click there, and then you drag. So what that's going to do is going to tell us how long this waveform is. And right there, that's telling us the frequency between these two cursors is 998 hertz, or 1 kilohertz, which of course matches the frequency counter down here, which is, it's doing that automatically, but sometimes it's nice to measure the time between two cursor marks. And you can see down there the time changes. This is exactly 1 millisecond between these two. But say I wanted to know, oops, okay, it's definitely fiddly. Okay, I wish you could basically click and drag and then click again or something. Okay, so we know that half the waveform is 499 microseconds, because 1,000 microseconds is 1 millisecond. So it is definitely nice that there are functional cursors here. And it looks like you can also, what's this first button do? none cursor. Okay, I see. Cross cursor. So these are like 2 points. Wait, I don't know. Okay, yeah, same. It has the same mechanics. So this measures the height and the width. And you can also just do a height as well. So like there, and this will tell us the voltage. So 2.07, okay, you go the other way. From the bottom up, and 1.98. So it's close enough to be able to figure out like the amplitude of a waveform by measuring specific points of it using the cursors. So if we move this waveform right here where the rise time is in the center, and then we turn up the time base, well, that's weird. It like moved around. Okay, that's a bit weird how it doesn't seem to stay. But you notice actually it's updating a lot faster, so that's kind of nice. Okay, with the sample rate much higher, notice the entire sample width is pretty small, but it's also no longer triggering properly anymore. Anyhow, I really don't like when you change this like there, how it, see how it moved? I'm expecting it to like stay in the same spot, but it definitely shifts around, which I don't love. Get to this. Okay, so we're getting to the limit of what this thing is capable of, I think. 10. Oh no, okay, we're still getting an edge. Oh, but look, it's all weirdly jittery. Even though the trigger, it'd be nice if I drew a line when you move the trigger. The trigger is right in the middle of that. It shouldn't be having a problem. That's because the trigger circuit in this thing is just not great. But it was $60, so what am I expecting? So triggering is super basic, edge triggering, auto, normal, or single. So I guess I go to single shot mode. You put it in single, notice it's stopped here. When I hit play, it will only sample 1 frame basically. Single shot mode is useful if you're triggering off one signal to look for another on the other channel, and the scope will sit there and wait for the trigger conditions to be met, and then it will capture that data and then you can look at it. And that's why these digital scopes are pretty cool and very useful over an analog scope. One of the original analog scopes, they don't have any capability of triggering and storing the waveform for you to scroll through and zoom into. There are some analog scopes, well, that have a CRT that can, but those are actually digital scopes just using a CRT for a display. But the truly analog scopes have no capability of storing a waveform. I mean, maybe certain ones do, like really high-end ones, but certainly none that I've ever worked with that are like the, you know, basic economy models. So that's one huge benefit to these digital scopes. And even this cheap one can do this stuff. Here in the utility menu, it's got some interpolation, but it's grayed out. I wonder why. Maybe that's a feature of a higher model that I don't have, or maybe I have something turned on that prevents me from using those features. It's kind of weird they're grayed out in my opinion. There is an intensity setting here, which, what does this let us do? Oh, okay, you can just adjust like the brightness of the dots and stuff. Waveform, I mean, this is pointless. On the old analog scopes, you could turn the brightness up and down on the waveform, and if sometimes they had a backlit reticule, I think it's called, with the lines, and you could adjust that as well. It's pointless on a digital scope like this, on a USB one that is. I kind of breezed over this before, but the triggering is only edge triggering. Edge would be like this right here, transition, and it's triggering here at this threshold. Now you can do a positive or negative slope, so it's either going up or down. More expensive scopes have way more capabilities, like even the VirtualBench, which is kind of simple, the triggering. It still allows you to do like up and down, so you can do both. You can also do triggering with delays, so it can trigger and then wait a specific time. Helpful if you're trying to capture a signal that you know comes with a certain delay after the trigger. Fancier scopes like the Rigol and maybe more expensive USB scopes have like fancy triggering off like SPI or all sorts of other signals. In fact, the Rigol can decode video, as in like NTSC or PAL video, and trigger off of certain scan lines, like way more capabilities than this has. But for basic work, I think this is totally sufficient. Looking at the horizontal time base, it pretty much must have a roll mode here, right? Oh no, it doesn't. 5 seconds. So that means it takes 5 seconds. What's it even doing? Oh, there we go. So typical oscilloscope roll mode, it means it like samples so slowly, and then it's good for seeing signals that change slowly. I don't know, like voltages from a power supply that go up and go back down. I don't know what it's doing right now. So theoretically, it should capture data every second, but I don't know. Doesn't seem to be doing anything. Oh, I'm noticing the manual here, it says it has math capabilities. It does indeed. So we hit that. Okay, so that's sort of useful. I don't really use this myself. It lets you add the A and B signals, or subtract or multiply, divide, or do a fast Fourier transform, which was like a spectrum analysis basically. So if you have a waveform, it uses the computer CPU to calculate the frequency components inside like a sine wave or something like that. And here we are, we're doing like a frequency analysis of this waveform, and it's not easy to see. Can I even move this around? No, oh, I gotta close this. So see this H here? But basically this would be, I guess, around 1 kilohertz here. Now say there was like a 1 and a 5 kilohertz, you know, we should see 2 peaks in here, but I don't see a way to measure the math. So it'd be nice if I just saw a peak here, you could click on it or something, and you know, it would tell you what it is. But measure only has channel 1 and 2. So, okay, I guess there's just no way to do it, but whatever. This is not like the most useful feature for troubleshooting old computers. There's an R button here, which is a reference, and I think what you can do is you can save a waveform and you hit load, and then you can load that in, and to save it, well, I have to click out of this, but I think it lets you, it loads this blue color waveform on here, and it just allows you to compare what you're capturing to what's been saved. So it's just helpful from a comparison standpoint. Here in the manual, it's showing how to use the interpolation settings, and it's grayed out. The interpolation helps when the sampling is of a frequency that's close to the maximum. So on step, you're just seeing like the actual A to D converter, like that's what it looks like. Then there's this linear interpolation, which sort of starts to draw lines. And then there's sine x over x, which actually takes the points and draws Bezier curves between them. Now, that gives you a false sense of what the signal is, because imagine this signal actually looked like this, like it was a stepped square wave. Well, it would show up as this when you have sine x over x turned on, which is not really how it looks. So it's nice to be able to change the mode to get a more accurate representation. Although it says here the default is sine x over x, which is going to be fine for the purposes of troubleshooting a computer. So there's the sample rate turned way, way up. Okay, so I just realized it says down here 48 megahertz. So I guess this thing, even though it's only a 20 megahertz scope, is actually sampling at 48 megahertz. You're gonna need at least double the sample rate to actually get any useful data, and even double is really pushing it. Think about this, CDs were 44 kilohertz, right? That was the sample rate on a CD, or is the sample rate on a CD. And when you look up the specs, the rated maximum frequency a CD can do is 22 kilohertz, so half of the sample rate. And that again is because that 44 kilohertz is enough to sample the top and the bottom. Now, when you're exactly half the sample rate, the problem is any definition of the signal, if you have a sine wave, is lost. All you're gonna get is the top and the bottom, or somewhere along that point. If it's a sine wave, it's gonna be terrible sounding. So I guess this thing can sample at 48 kilohertz, so that's good. It actually means that 20 megahertz, it should still be able to show something somewhat usable. Now, one thing I noticed, look at 5 microseconds. This is actually updating pretty quickly. I'm kind of shocked. It certainly would be nice if triggering worked though. It's just not working at all at this time base. I poked around a little bit more and I'm really not seeing any other features here. Like, this is it. It's very, very basic. But for the price, I think this is going to be functional enough to be actually useful. So let me grab a 64 and let's actually look at some real signals on it. All right, here is the ZIF 64. And what I like to do is grab a clip lead, clip it onto a ground point, and then stick this on the probe. It's not good for really high frequency stuff, but it just gives you more flexibility to than having the probe sort of stuck in one small place. Make sure you stick the boots together though, so you don't short stuff out accidentally. Let's pull this off. I'm going to change the scope to 2 volts per division. Set the trigger somewhere in the middle. And let's start right here on pin 2 on the RF modulator, which is the luminance signal out of the 64. All right, so we're just seeing what looks like noise, and that's because the time base is not nearly fast enough. So let's speed this up. And let's change this to 1 volts per division. And let's move the trigger up here. Okay. All right, so what we're looking at here is the actual video signal, the black and white part of it, coming out of the 64. The color or chroma signal is on a separate pin, so we can look at that separately. But this is giving us a very good representation that this machine is working. Now here's what I mean. If I turn this off, okay, so it's going to drop down. When I turn the power on, you're going to see these bumps go up and down, which is the sync signal. But if you have a black screen, all you're going to get is that line on the left side of the screen. And that is, so we turn this on, there it is. That's the line, that's the white line. And then you notice after a little while, we get all this. That's the actual scan lines that make up the picture. But right here you have a sync pulse, and then you have this peak right here. And that specifically is the white line on the left side. And let's do a test. Let's pop out the kernel ROM. There we go. And we turn the machine on. That's all we're gonna get. So it's a good way to confirm, for instance, that your 64 is at least powering up to some extent. But if you're getting a black screen on your monitor and you want to make sure it's not the RF modulator or your cable, you can actually probe the pin here and look at the data that's coming out and look at the signal coming out of the VIC-2 and see that this machine does have a black screen. So if we zoom out a little bit, we might see those, although no. Okay, and so these are the white lines that are happening like on every scan line, and sometimes it's not super low. And in fact, I don't know what's happening there. Like if we zoom in here, but because I zoomed out and the sample rate is pretty slow on this thing, it was actually just missing those altogether. So it looks flat here. It's not really flat. If we press play on there and we zoom in, okay, well it moves around when you zoom, and I gotta say that's pretty annoying. Okay, it's not triggering. So yeah, there it is basically. Anyways, I mean, we're actually unfortunately kind of near the limit of the capability of this particular scope. If I go up to 5 microseconds, we can no longer trigger anymore. So I have to say I'm a little disappointed that triggering is so rudimentary on this device, that it's not able to trigger on any of these faster time bases. I mean, there's a lot more time bases available here. Okay, this one just doesn't work. Let's see, none of these work properly. It's just all over the place. Nope. Maybe this one's working, so let's hit pause, scroll around. No, there's nothing to even see there. So it's running at 48 megahertz, and it just, I don't know, it's capturing little windows. You hit pause, nope, nothing usable there. And 5 microseconds, okay, there's usable signal, but it's not triggering. All right, so let's move over to one of the data bus pins here on the ROM that I have taken out. So there's a lot of activity going on. Now if I turn the machine off and on, you know, you can kind of see stuff happening. Let me zoom in a little bit. Does this even work zoomed in more? It's not triggering. I don't know. Yeah, I gotta say, I wish this worked a little better at these time bases, because this is right in the sweet spot for like working on one of these machines. Now, the thing that's definitely what you can do is we would be able to tell if there was a bus conflict. Like you see it's hidden up here near 5 volts and there's a little bit of a droop down here, but like say it was only going up to like here in the middle, I would definitely be able to tell that there's a problem. And in fact, if I switch it to 10 microseconds, which is the one that actually triggers, you know, I can turn the machine off and on and we can see all sorts of different activity happening on the data pins. Now this is kind of normal on a 64. When there's no ROM, it's going to act a little weird like this, and that's because the processor sees floating inputs kind of randomly. But at least I'm able to kind of make heads or tails of what's happening here. Now here's an example. I switched this over to 5, so it's not triggering properly, but we see this waveform on one of the pins to the ROM, and look, 1 megahertz. So it's measuring that speed properly, and I guess that's I think this is probably one of the select pins. So it's trying to select the ROM and that's not working. Let's hit play and turn the power off and on. Yeah, I think it's trying to read out of the ROM and oh, okay, so there, changed to that. Now, again, because I can't really zoom in anymore, I mean, I can, but if I hit play, oh, wow, it's triggering. It says triggered there. That's so weird, it wasn't triggering properly on those other pins, but this one is. Okay, triggered, yeah, it's working. Definitely not working on 5 nanoseconds though. Yeah, I mean, okay, I'm very surprised we're on 200 nanoseconds and that pulse is properly triggering. Let's switch the, so it seems like in the middle here, it's like a sweet spot. When we go over the edges here, it kind of comes and goes, but that is a usable signal. And look, 1.02 megahertz. All right, I'm a bit surprised. It just seemed to not trigger properly on those lower frequency signals. And on this one, it's working. All right, so now I'm poking around on the VIC chip and I'm looking for high frequency signals to see what this looks like. And it is not able to like give us an accurate capture of this clock signal. I think this is the, 14 megahertz one. It's kind of telling us the frequency here, but not very accurately. And at this frequency with this scope, we cannot trust that this waveform is correct. Now you see zoomed out, you see this like weird pattern going on. That's not really there. That's just the aliasing of the sampling happening. And so I'm gonna say that this scope is not really useful for anything over like 2 or maybe 4 megahertz. That's gonna be the limit of measuring signals with that. But here I am on the clock pin for the 6510 on this machine, and there it is, 1.021 megahertz. So like I said, 1-2 megahertz, it's able to show us that waveform, so you know that the processor on this machine is getting an appropriate clock signal. Okay, so the scope is now connected to one of the RAM chips on the data bus, and at 500 nanoseconds, again, it's the triggering leaves something to be desired, but it does still show us that we're getting pretty much good, valid TTL signals on this data bus line. So again, useful if we want to see if there's some kind of a bus conflict or some other issue. Okay, I plugged the same probe into the VirtualBench here, and let me just show you what the VirtualBench looks like in comparison. So the whole UI on this is so much easier to use. And here we are sampling at 5 microseconds. We were doing that on the other one, but look, I can go up to 2, to 1 nanosecond or 1 microsecond, 500 nanoseconds, still triggering with no issue. Plus, I really like that when you zoom in and out, it doesn't move around. Like, see this valley here? Move in and out, stays exactly the same place. So here we are at 100 nanoseconds, and there is, looking nice and clear. Now, if you remember when we looked at the other one on this same data bus pin, we saw very similar looking things with this sort of sloping marks here and a little bit of stuff in the middle and little glitches here and there. We're seeing the same information as we were on the Hantek. So it really does show that for something that costs just $60, it's far cry from the capabilities of the VirtualBench, but the VirtualBench is thousands of dollars. And this is 60. And for working on a slow 8-bit computer like this is absolutely good enough. Okay, conclusion time. Is this thing worth $60? I'm gonna say yes, actually it is. If all you need to work on is low frequency stuff or 8-bit computers like this is totally fit for purpose. I wish the software were a little less glitchy, a little more capable. I wish it didn't have that triggering issue, but the fact you can get a brand new 2-channel digital storage oscilloscope that does require a computer with 2 sets of okay scope probes, I'm amazed. I'm honestly amazed. This thing works so much better than I actually expected it to work. Would I recommend this over an old used oscilloscope? Well, if you can get one of the old ones for cheap, for the same price as this, you might be better off, especially if it's an old digital storage one like a Tektronix. I think there's some really kind of old ones there with they have bad LCD screens, but they work. It's almost certainly going to be more capable than this because it's going to have higher bandwidth, it's going to have good triggering that works properly. But on the other hand, that relies on you being lucky and finding one for cheap. And like I said, I looked around and I couldn't find anything that cheap. Everything was quite a bit more expensive than this. And if you were just a casual person with some very casual needs of repairing machines or having around the house, I really do think this is not a bad option. Now, I actually did order 2 other low-cost oscilloscope solutions to test out, and this is the first of the 3 I bought that I've reviewed and even tried out. So I can't say if those other ones are going to be better, but if you watch the channel, I'll review those, and of course I will compare back to this one to see what I think about it compared to this $60 one. But yeah, so far, not so bad. In fact, next time I do a repair on a machine where I need an oscilloscope, I'll use this. So yeah, we'll get some use out of it, see if it can actually help me fix something and where I don't have to resort to using the $2,000 device here on the bench. So with that, I'm going to end this video here. I will put links in the description if you want to buy one of these yourself. And I guess that's going to be it. You know, thumbs up if you like this video, all the usual YouTube stuff. Huge thanks to my patrons. Their names are scrolling up the side of the screen. If you want to become a patron, you can do so at the link in the description. And I guess that's it. Stay healthy, stay safe, and I'll see you next time. Bye.